Well, hello, everybody, and welcome to the September Virtual Planetarium with Pete Lawrence and myself, Paul Abel. And as ever, we will start with the inner solar system and working our way outwards. So, starting with Mercury, Mercury rises 90 minutes before the sunrise on the 1st of September. It's not massively bright at magnitude 0.6, and it's visible low in the east-northeast horizon in the dawn twilight. But it does brighten to magnitude minus 1.1 mid-month and rises about 80 minutes before the sun, so that's probably a better time to catch it.
That's not bad, is it? It reaches greatest western elongation on the 5th of September. It's in a reasonable position in the morning sky, because things in the morning sky before sunrise tend to be fairly high up at this time of year. Venus is in the evening sky at the moment, but you may not actually realise it. Even though it's at magnitude minus 3.8, it's just very low down and very hard to see. And it'll remain like that until we go through, probably until November.
Yeah, but
then it starts getting a bit of altitude.
But it is there, and if your telescope is fitted with setting circles, you can at least try and find it that way. So, but yeah, it's not going to become a good, easy object until towards winter, later the end of the year.
No. What about Mars then? Well, Mars is near the 5th magnitude open cluster Messier 35 on the morning of the 9th of September, and it passes 52 arc minutes south of the cluster's centre, if you're counting. You can't really tell exactly where the cluster centre is, but Mars will appear subtly brighter at mag 0.5 at the end of September. It's plus 0.7 at the beginning. So it's gradually getting brighter and it's gradually getting bigger when you look at it through the eyepiece of a telescope as it heads towards opposition, of course, which is in January.
Yeah, so it'll be a good opposition in the sense that Mars will come to opposition in UK skies very high in the sky. Unfortunately, these types of oppositions, which are known as aphelic oppositions, because Mars is furthest away from the sun when it comes to opposition, means that it'll be of quite a small size, so about 14, 15 arc seconds, but at least it won't be scraping the horizon. So even with a smaller disk size, smaller telescope should be able to see plenty of details.
It's quite an interesting thing, isn't it? I mean, the higher altitude does make a huge difference with Mars. It just stabilises the view enormously.
It does, and of course it helps that it's the colour red, because shorter wavelengths of light are more affected by bad seeing than the longer wavelengths. So, we have to make the most of it, of course, because Mars moves quite quickly. So blink and you miss opposition and it's getting small again. So we'll have to make the most of that in January. Okay, well, moving on. The planet Jupiter now. This is an improving morning planet shining at magnitude minus 2.1 on the start of September and starting to rise now in the evening at 22:30 UT. It gets to an altitude of over 40 degrees under relative darkness. So Jupiter's becoming a very good target. There's some news recently. The Great Red Spot now on Jupiter, which is this large storm that's been going for many hundreds of years, is really quite a lot smaller than it has been in many years. So we'll have to see what's going to happen with that.
Do you think it's going to disappear?
I don't know. See, the problem with predictions with planets, particularly gas giants, is you say what you think is going to happen, and then they do something completely different. I think it'll either disappear and then reappear as some sort of global event that'll happen in the South Tropical Zone, this area where the Great Red Spot sits in. Or it might just vanish and that'll be it. I mean, there's no way of knowing, is there? That's why we have to keep observing.
Absolutely. It's very exciting, actually, that's going on. On the 30th of September, Jupiter appears 3.3 degrees east-northeast of Messier 1. I bet you're setting your diary for that, Paul. M1, of course, is the Crab Nebula. And Jupiter, which will be extremely bright, minus 2.1, will be much, much brighter than the Crab Nebula. Crab Nebula is quite a tricky thing to see, actually. If you try and look for it with binoculars, it's just the faintest of smudges. And even through a telescope, it can be quite tricky as well, can't it?
It can be. I've never seen it in a finder scope or binoculars. I have seen it with my 8-inch telescope and my 12-inch telescope, and I have to say the difference of those extra inches with the 12-inch made absolutely no difference whatsoever. It was a featureless blob in the night sky. So I have seen it under dark sky conditions as well, away from Leicester. And it's incredibly difficult to see anything. It's just a sort of diffuse blob. But it's nice to say you've seen it.
It's a great thing to photograph as well. It does, when you start to get the structure in it, the tendrils that sort of surround the crab pulsar and in that sort of structural cage of glowing gas, if you like, that's quite satisfying when that starts to come out. And it takes a little bit of doing, but you can get some nice pickies of it. The good news is that on the 30th of September, both the Crab Nebula and Jupiter climbed to an altitude of, wait for it, 60 degrees under dark sky conditions.
Practically overhead.
It is overhead. Let's say it's overhead.
Yeah. Well, yeah, so that'll be a nice event I think more for photography than for visual, but it's a nice event to have.
Yes, okay. Well, Saturn reaches opposition on the 8th of September. And that's the time when the planet is best presented to us. It'll be shining at magnitude plus 0.2, which actually isn't bad for Saturn, amongst the stars of Aquarius. And it reaches an altitude of around 30 degrees when due south, which is actually, doesn't sound a lot, but it's a lot better than it's had over the last few years.
It is. I mean, for the last few years, I've only been able to view Saturn when it passes between the gaps in the house. So it's about a 15-minute window. And that's it. And it doesn't take much. And that's not constant every night. So it only takes about a week of cloudy weather. And it's doing that, passing through the transit of observation quite rapidly. So it's been very difficult. So 30 degrees up, I'm happy with that. We'll take that. It means
me too.
The planet is quite visible. Of course, we should say something about the rings now. The rings of Saturn are really closed up, and they're kind of like a faint slither. This is because we're passing through the ring plane of Saturn next year, and this means the rings will be even thinner. So the effect that we watch out for near opposition, this Seelinger effect or the opposition effect, where the rings appear to really brighten up a few days before and after opposition, is not going to be as prominent, but I think it will still be noticeable.
Do you? It's quite an interesting thing, isn't it? Because they are really very narrow now. I mean, Saturn is tilted by about 3.7 degrees at the moment, which is not very much at all. And they just look so narrow when you look at them through the eyepiece. And it will be interesting to see how strong the opposition effect is with it.
Yeah, I have to say, I haven't actually looked for it because the last ring plane crossing, I don't think it had occurred to me to watch out for it, but this time I will do. And of course, it would be interesting to do a system of observations from now till the rings start to open up. So you've got, because there might be observational changes in the opposition effect as the rings tilt up and become a narrow line and edge on and then open back out again. It's not necessarily going to be a uniform series of effects all the way through these different types of oppositions. There might be, more of an effect when the rings are closed up on the north side than the south side. So there's every reason to watch this, and I'm not aware of any studies about this or any observational effects about this. There may be some, I don't know, but this is why it's worth starting to do regular systematic observations so you can build on record and answer some of these questions.
Yes, I've not seen anything on it. I have looked, so it will be interesting to actually do the observation itself. Okay, well, the ice giants then. Uranus is a morning planet well placed for observation from mid-month. It has a peak altitude of 56 degrees, and that's because it's fairly close to both Jupiter and Mars at the moment. They're all in Taurus, actually, so Taurus is quite a rich planet, a rich constellation for planets. Neptune reaches opposition on the 21st of September. That'll be a very exciting time. Well, it won't, because Neptune is so far away that opposition, even though it reduces the distance between us and the planet, it's so far away, it makes very little difference, really. It still looks like a very tiny planet through the eyepiece.
Yeah, so I don't think it's going to make that much difference, really. Okay, well, let's move on. We've got some nice specials this month. So on the 2nd of September, Saturn's largest moon, Titan, appears immediately south of Saturn's south pole at 0252 BST, which is 0152 UT. So that's a nice thing to look out for.
It is, and we may seem strange pointing out when Titan is close to Saturn's south pole, because it'll always pass Saturn's south pole
Yeah.
as it goes around its orbit. But what we're pointing out here is the fact that because the ring plane crossing is imminent in March of 2025, the tilt angle is now sufficiently low that Titan is getting close to interacting with Saturn itself. So it'll start transiting the planet, and you'll get Titan shadow transits as well. Actually, there have been some interactions already. There's been one or two back in August. There's one at the beginning of August and one in July, but there will be a whole sequence of them happening very soon. So that's why we're pointing out where Titan is at the moment. But also on the 2nd, there's a waning crescent moon, which is very thin, which sits 2.3 degrees from Regulus just before sunrise. So it'll be quite a nice sight, that actually. It's less than 1% illuminated. So it's a nice thing to look out for, because it tends to be fairly well positioned, a waning crescent moon, at this time of year as well, in the dawn twilight.
That's a nice thing to watch out for. On the 3rd, we have Dione and Tethys, and their shadows are centrally placed on Saturn at 0422 BST, that's 0322 UT. That's be a really nice thing to look out for. So as the Saturn's rings tilt starts to decrease further, as Peace just said, we get more of the satellites and their shadows passing in front of Saturn in these types of transit events. They happen quite a lot on Jupiter, but because Saturn has this pronounced axial tilt more than Jupiter, we get to see a lot more of it from here. So that event on the 3rd will be worth watching out for. On
the 7th, it's another planet's moons which are interacting when Ganymede can be seen transiting Jupiter's disk between 0004 and 0215 UT. Ganymede is it's the largest moon in the solar system, and when it passes in front of Jupiter, it's quite a sight, actually. So if you've got a telescope, see if you can grab that. And on the 13th, we have another Ganymede event. This time, Ganymede's shadow transits Jupiter's disk between 2238 and 0050 UT, with Ganymede itself transiting between 0400 and 0620 UT. So that's, again, visible under daylight conditions on the next day, the 14th of September. Yeah. And it really is worth getting these, because Ganymede transits and their shadows are quite rare, because Ganymede is quite a distance from Jupiter. So when these events happen and they're well placed from British skies, it's worth going out and getting them. Well, on the 17th, just after midnight, technically into the 18th of September, if you like, Titan once again is close to Saturn, sitting 4 arcseconds south of Saturn's southern pole. And on the 18th, this morning's full moon is the harvest moon for 2024, and it's going to undergo a small partial eclipse. Maximum eclipse is at 0244 UT, and this is a small lunar eclipse taking place in the early hours of 18th of September. So this is an interesting one, isn't it? It is, yeah. It is a very small event. You can get the full details of it in the magazine, but when you get a little clip of the moon going into the umbral shadow, it can be. It looks odd, but you can't really see visually any colour like you would normally if you had a total eclipse of the moon, for example. But it's worth having a go and seeing whether you can pull out any colour with a camera. You might be able to record the sort of reddy hues which are in the moon's umbral shadow. And you'll see the effects of the penumbral shadow, which is the weak outer shadow of the Earth as it crosses the moon's surface. And it looks like a shading, getting darker and darker as you get close to the umbra. So it's worth going out and having a look for. It's just a pity it is so small, but any eclipse is welcome, isn't it? It is, and worth trying for. All right, well, on the 21st, we're back to Jupiter, because Ganymede's shadow, again, is in transit across Jupiter's disk between 0240 and 0452 UT. And on the 22nd of September is the Northern Hemisphere's autumn equinox. So Yay. Autumn officially starts after that. Which is, of course, the time of the year when the expansion of darkness is at its highest rate. Yes. So that's something to cheer on, actually, because it's useful having longer dark nights, isn't it? Okay, on the 25th, we have Titan sitting 4 arcseconds north of Saturn's North Pole. That's around 2222 UT. And on the 30th, Rhea's shadow is in transit across Titan's disk from 1950 to 2316 UT. Have you ever seen these smaller satellites of Saturn, or smaller major satellites of Saturn, I should say, interacting with the planet before, Paul?
I have, actually. So I have seen Rhea's shadow at Rhea, but it was very difficult. But that was with the 8-inch telescope, and Saturn was higher in the sky.
Right.
I've never seen a Titan one. I've seen a Tethys shadow, but with a large telescope. So I think some of these are possible, but you've got to have really keen eyesight. And I think, to be honest, for most people, a 10-inch telescope is going to be necessary to see most of these. But, of course, if you've got access to photography, then you can use a smaller telescope to pick these up.
Yes, indeed. And as you say, the Titan interactions, which are due to start properly at the end of the year, should be much easier to see and image. They're quite interesting, actually, because Titan transits of Saturn, I can remember the last time we were near a ring plane crossing. That was back in 2007, wasn't it?
Yeah, a long time ago.
A long time ago. It's every 15 years or so. Makes you feel old. The Titan interactions with Saturn, you have to get your timing right because of the orbit, the orbital period of Titan. If it's badly placed for one of those interactions, it'll be badly placed for a whole sequence of them. And I can remember back in 2007, I didn't get one which was really well placed for me. So this year, as we go into the end of the year, you'll start to see the shadow of Titan crossing Saturn's disk. But the Titan transits themselves are really quite badly timed, and they will be happening during daylight hours. You can see Saturn during the day, but it's much harder, obviously. But the way the Earth and Saturn jostles about in their orbits means that as we go through to the end of 2025, we're still quite well sideways on to Saturn, and we will still get to see interactions with Titan. And there are some fantastic Titan transits coming up at the end of 2025.
There are, and I'm looking forward to them because I had even worse luck than you last time. So it was academic in a way that the Titan transits were all badly placed because the skies in Leicester didn't clear for months. So, it doesn't make any difference.
It was pretty poor. I do remember actually sitting in Patrick Moore's garden with Patrick. We were filming a Sky at Night talking about these events. And I can remember Patrick sitting there with this rather sad-looking inflatable Saturn, which didn't have quite enough air in it, and the rings were drooping at each side of the planet. So, that's a
set the tone, didn't it? Oh dear. Yeah. Let's hope we get better luck this time. Shall we move out into the night sky then? Because the stars and the constellations are now starting to change, and the stars of autumn are back in force. And the charge is led by the magnificent flying horse Pegasus, whose constellation really is marked by 4 bright stars that depict a large geometrical asterism known as the Great Square of Pegasus. I think the Great Square of Pegasus is quite possibly overstating it a little. It is a large area of sky, but the stars that make up the four corners of the of this kind of square are not very particularly bright. But once you have found it and seen it, you won't lose track of it again.
It's weird, isn't it, that happens? It's just it is I mean, it's not a square. I've seen it from the southern hemisphere, and you think, what's happened to the Great Square? Because it looks distorted. And I think you've just got so used to the shape of it from the northern hemisphere that your brain automatically corrects the fact that none of the sides are of equal length.
No, that's right.
But it is something which is recognisable and part of autumn. As autumn rotates slowly into view, the dramatic summer constellations get displaced to the west, but we still have the summer triangle asterism earlier in the evening. It's quite well placed, actually. And that means we still have the Milky Way. In fact, you can see the Milky Way quite well because as the darkness expands, so the drift to the west of the Milky Way is counteracted to a degree. So if you get your act together, and as darkness really falls, you can still see the Milky Way in a really good position. So you can see all the way down to the core region, which is in Sagittarius. But it won't hang around much longer. It will gradually drift to the west, and we will lose that lower part of it. So get out there and have a look at that if you can.
This is actually a good time to get it, because the summer Milky Way is such a much more spectacular effect than the winter Milky Way. And if you've not got access to a large telescope, just a pair of binoculars, scanning down the Milky Way through Cygnus all the way down south to the southern constellations like Sagittarius is really worth doing, because it's all the different clusters. You can see the arm of itself as it passes through Cygnus is broken up because of dust between us and the light of the stars. It's just a fantastic, easy win to get. So
yes, it is.
Make the most of this before it disappears, because the winter Milky Way, by comparison, isn't nowhere near as spectacular.
It's puny.
It's puny. You heard it here first. We won't have it in the house, the Milky Way in the woods.
Well, talking of puny skies, I shouldn't say that about this region, but it always, I don't know. I was going to say it's always a bit watered down, which is a very bad pun.
Oh,
because
dear. That's one of Pete Lawrence's jokes. We must be coming on to Capricorn as the sea goat.
Well, that's ruined that, hasn't it? Okay, so looking south in the hours before midnight will deliver a region of the sky which is known as the sea, because it's got lots and lots of water-based constellations, and they're all not that distinctive, really. I mean, Capricornus, the sea goat. Okay, we've spoken about the sea goat before. We don't really know what a sea goat is, apart from the fact it's a very ancient constellation. So it's I think it's depicted in Babylonian star catalogues.
Yes, I think it is.
It's one of their gods, actually, that where the name comes from. So a sea goat is a mythological beast from the top half of a goat and the bottom half of a fish. Okay. And it looks like, some people describe it as looking like a smile.
It looks more to me like a slightly squashed triangular sandwich than it does a smile, but there we are.
Yeah, okay. Well, the constellation is best recognised by virtue of the two pairs of middle brightness stars at its eastern and western extremities. Further to the west, the star Alpha Capricorni. If you look carefully at that star and you have good eyesight, you should be able to spot that it's actually fairly matched close naked eye double star. The components are 3.6 and 4.2, separated by 6 arc minutes.
So that's pretty good. Actually, we should say that the two stars, although double stars, they're not actually physically linked. So this means that there's no gravitational attraction between them that's keeping them in a mutual orbit around each other. They're simply an optical double. That means that the two stars just happen to lie in the same part of the sky very close together, making it look like that they're binary stars, when in fact it isn't. It's just a line of sight effect.
What is the chance of that?
What is the chance of that?
Very, very high, actually. A little further to the south of Alpha lies Beta Capricorni, which is a tighter double, comprising a mag plus 3.4 primary and plus 6.2 secondary, separated by a narrower 2 arc minutes. The pairs, I suppose the best way to see that is through binoculars or using a small telescope. And unlike Alpha, Beta is a true double. The stars are in mutual gravitational orbit around one another, separated in space by 1 trillion miles.
Yeah, so that's an interesting one to watch, providing you've got a clear horizon and you can see down that far. But also in this constellation, hidden away in the southeastern corner, is an infamous 7th magnitude globular cluster known as M30. Now, this globular cluster is the problem Messier cluster that can mess up a Messier marathon attempt for the UK. Because if you start a Messier marathon and Capricorn isn't well placed, then you're not going to get M30. So it can scupper it. You need to start your Messier marathon at the right time in order to grab M30 to check it off the list.
Yeah, it's normally March, isn't it, when the window of opportunity arises to grab all of the Messiers in one night, apart from M30.
Yes, so that's
very, very irritating. Okay, well, above Capricornus, we keep with the watery theme by entering the constellation of Aquarius, the water bearer. And that's a tricky patch of sky to navigate because there are no really bright stars there. I suppose the most distinctive thing is the asterism known as the water jar, or as we sometimes call it in modern times, the steering wheel, which really irritates the purists. Sorry, because it looks like a central star with 3 stars arranged around it at 120-degree intervals, like the spokes on the steering wheel. The water jar is the traditional asterism there, which is supposed to be where the water is coming from that Aquarius is pouring.
Yeah, but the steering wheel, I think, is probably going to be more recognisable to most people today than a water jar. But there we are. Despite its sprawlingness, so Aquarius does spread over the sky quite a bit, it does contain a number of deep sky objects. The most interesting one, perhaps, is NGC 7009, also known as the Saturn Nebula.
Oh,
and
yes.
it's called this because it resembles a tiny version of the planet Saturn through the eyepiece. Not sure. It looks a bit like Saturn to me, but then I've not got particularly dark skies. I suppose it might if you view it through a large telescope in a particularly dark sky.
The ANSI, the little extensions either side of it, are quite faint.
Yeah.
I've taken a photograph of it before, and it does look sort of Saturn-like, but obviously it's a lot fainter than it. I suppose the big thing in Aquarius, and then I'm going to ask you a question about this in a second, but is the famous Helix Nebula, NGC 7293, which is an amazing planetary nebula. It's very large. It's over a quarter of a degree in diameter, I should say. And it appears like that because it's one of the closest planetaries to us, lying at a distance of 700 light years. So my question to you is, have you ever seen it?
No.
No, I haven't.
Because it's so low down, but also it's going to have a very low surface brightness.
Yes, it will.
So I find, for example, M33, the triangulum spiral, to be incredibly difficult. So I think this would be even harder. And so I've never seen it with visually. I've only ever seen images of it because I think it would simply be too difficult, even with a large telescope.
Yeah, I agree. I've never actually tried to photograph it either, which I'm always astonished. I need to get my act together there and actually do that. Okay, well, let's bring this virtual planetarium to a close. But just before we go, it's worth saying that obviously next month is the big month for a potentially special comet. We don't know what it's going to do yet, so you'll have to tune in to the next virtual planetarium to find out about C 2023 A3 Sushishan Atlas. It is going through perihelion on the 27th of September, but it'll be really close to the sun and really difficult to see. So it's sort of mid-October it starts to become visible. So it's quite exciting. Keep tuned. Anyway, thank you very much, Paul.
Thanks, Pete.